Power system analysis per unit series. In this video, we will be looking at a numerical problem and we will solve one numerical problem related to a power system and we will convert some parameters to per unit values. I have already drawn the example diagram, which is the system single SLD single line diagram. We have one generator which is 50 MVA rated 15 kilovolt and its impedance is 0.20 per unit. Transmission, we have transmission on, but before this we have transformer 1 and transformer 2. Transformer 1 has a rating of 50 MVA and it is rated at 11 kV and it is a step up transformer, so it convert 11 kV to 132 kV. Then we have transmission line and its transmission line impedance is 25 plus J75 ohm. So this is the impedance which is given in the actual value ohm. We will be converting it to per unit also. Now moving forward, we got another transformer which is Y delta connected and its rating is 60 MVA 132 kV and it stepped down 132 kV to 33 kV. After that we have a bus bar and two loads are connected, M1 and M2, motor 1 and motor 2, both are three phase motors. This is rated as 30 kV 30 MVA and its impedance is J0.15 per unit. So note one point that here the load impedance is given in per unit, but the transmission impedance is given is in the actual values. It is not given in per unit. Also the generator side impedance is also given in per unit, so this will be treated as old values that we have already discussed in the previous lectures. This is also the per unit value, which is the old per unit value. Okay, and this will be treated as the actual value. So coming to the solution, we'll first select a base value for all the system. So according to that base value, we'll be converting all values to that common base value. So let's say we select for the power rating, for the power we select 50 as a base value. So that will be our base power, which is SB is equal to 50 MVA. So you can select any value. Better to have a value which is greater value in the numerical. So I selected 50 as base value, and for voltage I will select 15 kV as my base value. So I have selected 50 MVA as base value and I have selected 15 kV as voltage base value. So all the values, this impedances, all the values will now be reflected and converted according to these two base values. So remember, this will be our standard base values for the all the numerical parameters. So moving from left to right, we have number one, generator. So first we will convert the generator impedance to per unit value. It's already in per unit value, but we will convert in it to the new per unit value, that is that new per unit values will be according to these new base values. So as we have already selected, as we have selected the 50 and 15 kVA, so for generator the 0.20 per unit will not be changed because it is already calculated according to 50 and 15 kVA. But to show you, let calculate and apply the formula. So generator reactance, which is Z old, is equal to Z old, the old value is this one, 0.20 per unit. Okay, to convert Z old to Z new, we already discussed formula in previous lecture. If you haven't watched the previous lecture, I'll give the link in the description. Also check the I button so you can find the previous lecture. So Z new is equal to Z new. Now we will convert this old value to new value. So this new value will be according to the new base values. Okay, is equal to Z old multiply, that equation will be used again, VB VB old by VB new whole square, and again SB old by SB new. Okay, so here the Z old is 0.20 multiply, what is VB old? Now if we are talking about the generator, so for generator the VB old is 15. Okay, so it will be 15 divided by what is VB new. We have selected VB new, which is this one, so I can write as VB new, which is also 15, which is also the generator value we have selected. Okay, so I'll write 15. So these values will be cancelled out, so that's why I was talking that the generator reactance will be remain same. Multiply SB old is also which is SB old is 50 MVA, this one, and SB new is also 50 MVA. 50 by 50. Okay, so all these values will cancel out and we left with the this. So for generator the Z new value is remain same. The second component in the SLD is our transformer, which is T1 transformer. So I have written the impedance which is given in per unit for the T1. So for T1 we have given with that impedance as J0.10 per unit. So this will be our Z old for T1, and 50 will be the SB old for T1. Also let me write down the T2 impedance, which is also given as 0.12 per unit, J 0.12 per unit. So this is Z all for T2. So first we will calculate for T1. Okay. Now here let's follow the same formula for transformer 1 reactance. Okay. So the formula Z new per unit is equal to uh, Z old, okay, into VB old by VB new all square multiply SB old by SB new. Sorry, this will be SB new by SB old. Okay. Also, we'll make correction here. SB new by SB old. Okay. Putting the values in this equation, we have Z old given as J 0.10 multiply old value of transformer 1 VB old for transformer of T1 is equal to, which is 132 kV. Okay, so it is 132 divided by the VB new will be 180. Let me explain why we go to VB new as 180, because we have selected VB new here as 15 kV. So what happened is we have selected 15 kV, so we are coming from the left to right. This value here is 11 kV. The transformer is stepping up this 11 kV to 132 kV. Okay, so the 15 now we have selected new value as 15 kV, so this 11 kV will be changed to 15 kV. Okay, 11 kV will be changed to 15 kV. So if the primary side of the transformer is changed, the secondary side will also be changed. If we have increased this primary side of transformer, then obviously the secondary side it is step up, so the secondary side will also be increased. So to find that, we will find it by doing the ratio formula 132 by 11 into 15. Okay, so it will comes out as 180 kV. So we increase the primary side a little bit from 11 to 15, and the secondary side goes up to 180. So now this is our new value. Okay, so that's why I have put my VB new substituted as 180.
Okay, here you can also use the primary side values of transformer, which is 11 kV, the old value, and the 15 is the new value. So 15 kV, you can also use the primary side values. So the answer will be same for both, whether you want to use the primary side
Now
values or
SB
whether
new
you
is
want to
also
use
50 and
the
SB old
secondary
is
side
also
values.
50. As you can see here, SB old is 50, SB new is 50. So this will give answer as J 0.037 537 per unit. Okay. This is for transformer 1 Z new per unit. Now in SLD we have next the transmission line. Okay, note one thing, that the transmission impedance is given in actual value. Okay, but the transformer and the generator values of impedance were given in per unit value, PU. Okay, so for transmission line we will not use that formula. This one we will not use this formula. We will use the ohm Z ohm formula, because the value of impedance of transmission line is given in ohm. Okay, which is actual value. So the next thing is transmission line. We will be using Z per unit, or I can say, yeah, Z per unit is equal to Z ohm and SB by VB square. So this formula we have already discussed in the previous lecture. So substituting values, so by calculating it will comes out at 0.835 plus J 0.1157, and it is now in per unit. So for transmission line we have this per unit value calculated now. Moving forward, and we have in the SLD the next component is transformer 2. So this is the T2 transformer, and again the impedance value is given in the per unit, which is the old value. We will update this per unit value according to these new base values. Okay, by using the same equation. Now here the old value is 132, so this old value is now updated as 180. Okay, and this will also be updated. We will calculate this. The S old is given as, this is S old 60 MVA. Transformer to impedances, or impedance, transformer to impedance. So using the same formula, Z new per unit is equal to Z old per unit, and VB old by new whole square multiply new by old, SB new by SB old. Let's do one correction here in the SLD, in the parameter values of the T2. So as we know, we all the value of this T1 is 131.6 kV. Okay, because in the practical scenario we would have little voltage drops, so that's why the 132 kV will be dropped down to 131.6. So this is given in the numerical problem. Now we have, this will be the 131.6 kV is the old value. Okay, and the new value is 180. So Z new per unit is equal to Z old per unit. Okay, so the old value is given as J 0.12 multiply 131.6 and divided by 180, which is a new value square. Okay, now multiply SB new. What is SB new? SB new is 50. What is SB old? Let's see. The SB old is 60 MVA for T2, so it will be 60 MVA or MVA. MVA and MVA will cancel out, so that's why I'm not writing it down here. By calculating it, we will get the answer as J 0.05 per unit. This is Z new per unit for transformer 2. Okay, if you have confusion in converting these values like new and the old values, let me give you a little explanation here. As we have converted, first we have converted this 11 to updated value. So this 11 was updated as 15. So when this 11 is updated, obviously the 132 will also be updated. So it was updated to 180 kV. Now according to the new base values, the 11 kV, sorry, the 180 kV will be transmitted. So this primary side of T2 will have now 180 kV is new values. Okay, so that's why here the new value is also 180 kV and the old value was given as 131.6. So in old value you can see it is not 132 kV like this. We have little bit voltage drop between them, but in the new updated value for the voltages we will not consider the voltage drops. Hence in this way we will be consistent with the base values, the new base values, okay, for all the system. So for T2 the new value is 180, you got it now, and the old value is 131.6. Now in SLD we have the last term which is loads. So the loads are three phase loads, motor 1 and motor 2, and the motor 2, let me write the motor 2 ratings which is also 30 kV and it is 20 MVA. Okay, and its reactance impedance is 0.15 per unit, J 0.15 per unit. And now we will convert the motor impedances to per unit. Motor 1, okay, using the same formula, Z new per unit is equal to Z old into VB old by VB new square into new by old. Okay, so the motor 1 Z per unit value is given as J 0.15, multiply the old value. The old value is given as 30 kV. Already given value is 30 kV, so it will, this will be the old value, old VB old. Okay, the SB old is this one. Okay, and this one, this is the Z old, we already written this one. Now now 30 kV is the old value. What will be the new value? The new value will be according to this. If we got 180 kV instead of 131.6 kV, if we got 180 kV here, then this 33 kV will also be changed. So let's find how it will be changed, and the value will come out as, I think so, 45 point something. So it will be 33 by 131.6 multiply 180. So this will be equal to 45.12 kV. So now this 33 kV will be updated to 145.2, and these motors will have experienced 45.12 kV is new voltage. Okay, so let's substitute the old and new values for voltages as well. The old value is 30, the new value is 45.12 square into the new value is 50, the old value is given in the numerical as 30 for the power s. Okay, so by calculating this we will get 0.1106 per unit. Sorry, it is 0.0106 per unit. Okay, so this is for the Z new per unit for motor 1. Now let's find the motor 2 value. Z new per unit is equal to Z old into VB old by VB new SB new by SB old. This formula is very simple to remember, like Z old into VB old by VB new and new by old by new by old. Okay, so substituting the values, we have given the Z old for motor 2 as 0.15, J 0.15. VB old is same, and VB new will also be same because the both the motors are connected in parallel with the bus bar. Okay, so the voltage for this is 45, and for this will also be 45.12 kV. So it will be 30 over 45.12 square multiply 50, and the old value for the S is 20. Okay, so it will come out as J 0.1059 per unit. This is Z new per unit for motor 2. Now we will make impedance diagram. So first of all we will have the generator. So and this is the generator, and this will be the generator reactance. Then we have transformer 1. Then after transformer, if you remember, we have transmission line. So we have transmission line, then transformer 2. Okay, and then we have, so let's say this is the transmission line, because in transmission line we have resistance and reactance both. Then transformer 2, and then we will have load which is parallel connected. This is M1, this will be M2. This is generator. Now by putting values, this was J 0.20 per unit. Okay, and this is T1 transformer 1, which is 0.053 per unit. The transmission line was 0.08, J 0.115 per unit. Okay, then the transformer 2 was J, this is T2, this is TL. Transmission line, the transformer 2 was 0.05, per unit. Motor 1 was J 0.0106 per unit, and motor 2 was J 0.1059 per unit. So this is the impedance diagram for the numerical problem. That's it guys for today's video. If you have any question, do ask in comment section, and in the next lecture we will be looking at the per unit impedance of transformer. So we will derive some equations for transformer, how we convert the primary to secondary and secondary to primary. So we will be looking at the transformer ratios. All right, that's it. Till then, take care. Allah Hafiz.